Today, we're going to talk about the theorem on friends and strangers. The theorem states that in any group of 6 people, there must be a 3-person friend group or a 3-person group that are mutual strangers. So for example, in this diagram, it shows that there are 6 people, and each of these people are connected with each other with either a red line or a white line representing different relationships. So here we can see the theorem holds because, for example, here, 1, 2, 3, there is a white triangle in between them. That means there is a 3-person group that are mutual strangers. Let's look at another example. Here, it's also the same thing. There are 6 people, and here there is a red triangle, 1, 2, 3. And in this case, there is even a white triangle between these 3 parties. Cool. So let's go to the proof of this theorem. In the proof, we'll consider this particular person. This person has 5 relations. So this person is either friends with more than 2 people or strangers with more than 2 people. The reason why this is because if he only has up to 2 friends and are mutual strangers with up to 2 people, the number of relations he has does not add up to 5. That's why this person, given that he has 5 relations, he needs to be friends with either more than 2 people or be strangers with more than 2 people. So with this, we'll assume that he is friends with more than 2 people. So this means he is at least friends with 3 people because the next integer after 2 is 3. So remember that he is at least friends with 3 people. Okay. Now, that can be shown in this graph like this. So remember we were considering this person, and since we now say he is at least friends with 3 people, that means we can color these edges red, right? Okay. And since we want to prove that in a group of 6, there will be a 3-person group, 3-person friend group, or a 3-person group that are mutual strangers, let's try and examine the relationships among his 3 friends. Because wouldn't it be great if we can prove that there is actually a red line in between these 2 people? Then we are guaranteed to find a red triangle, right? So let's backtrack a little bit, and now we can see that when considering the relationships among these 3 people, these 3 friends of his, there are only 2 cases. The first case is there is at least one friendship among his friends. So it's either here, there's a friendship here, or there is a friendship here, or there are friendships in both of these pairs of people. In either case, it is that there is at least one friendship among his 3 friends. So what this gives us is a red triangle, like we hoped, right? And in the second case, in the disjoint case, if these people are all not friends, like none of his friends know each other, then there will be a white triangle. And that also satisfies our proof, right? So this is how we prove that in any group of 6 or more people, there will be a 3-person friend group or a 3-person group that are mutual strangers. So why does this proof work? It is because we have established that there is at least 3 edges of the same color coming out from any vertex. And among the vertices that are connected to this mutual edge by the same color, there is only 2 cases. One case is that there is at least one edge of the same color, thus completing the triangle, the red triangle. And the other case is that there is no edge of the same color, and that will create a triangle of a different color. To recap, in this video, we've learned that the theorem on friends and strangers says that in any group of 6 people, there must be a 3-person friend group or a 3-person group that are mutual strangers. We used 2 random examples, to see that this theorem indeed holds. After that, we did a proof. Step 1 of the proof is to establish that this random person will have at least 3 friends, that he's at least friends with 3 people, because he can't be only friends with up to 2 people, or strangers with up to 2 people. It is because it wouldn't add up, the number of his relations will not add up to 5, which is what this theorem's setting requires, because it is a group of 6 people, and this person will have 5 relations. Right? So after step 1, we went on to consider that given that he is at least friends with 3 people, we drew this diagram, and then we now considering the relationships among his 3 friends. And in examining the relationships among his 3 friends, we've noticed that there are only 2 cases, where the first case is that there is at least one friendship among his 3 friends, thus making a red triangle, or the other case will be that there is no one are friends within his 3 friends, thus making a white triangle. And this ends our proof.